This is an open lecture. It's the last lecture of the term. It's left deliberately open in case anyone has any questions about any of the content in the course. If we can have this lecture for the full length of the time or cut it short. Entirely up to you guys. So the course website open here. Yes?
Can I just ask, I guess, in order to help us understand what we need to study, what is the nature of this final? Is it kind of quizzical, do you yes or no, or?
Right. So there will be a combination of multiple choice and short answer, and of course a version of the Kaggle competition, individual. So the short answer, the multiple choice is true, false, A, B, C, D, yes or no, stuff like that. The short answers are I don't want to. Things it's okay. It's open book, so you can consult any resource on the website or link to off the website like Wikipedia. So that's your notes, the lectures, everything, homework assignments. It's all completely open book. You shouldn't view it as a memorization type of exam. So the type of questions we would ask is things like, here's a kind of a interesting function. Can you derive a gradient? And if you've learned stuff from the first few lectures, if you learned stuff from the deep neural nets lecture, this should be a straightforward exercise. Stuff like that. Things like, tell me about the bias variance trade-off in this particular scenario. Do you think the model has too much bias or too much? Do you think the model class is suffering from too much bias or variance, or is it just right? Things like maybe some matrix properties, like if I transform this latent variable space, doing something that looks like SVD, what some properties of the output of that space, stuff like that. Yeah, those would be the short answer type questions. Yeah.
For the Kaggle competition on your Piazza post, you said the best teams can get to present their work.
Yes.
Is it individual or is it teams for the Kaggle?
Oh, I'm sorry. I wrote that post late at night. And it's the best individuals. Excuse me. I'm sorry. I need to. There's probably a bunch of clarifying questions on Piazza that I haven't gotten to yet. It's the best individuals. I'm sorry. That's a typo on my part. So it's the best individuals. We'll have an opportunity to present to the CEO. Yeah.
So we originally were going to have just an exam.
Normal final. Yeah.
Expectancy of this new model?
So the original exam from previous years was supposed to take about 5 hours to do. Now the new one's supposed to take about 3. So we're shaving. Those 3 and 5 are for approximate numbers. You should think of it in terms of we're going to shave about a third of the 25% to a third of the exam off. And the understanding is that the Kaggle competition shouldn't be some sort of crazy mental time sink. For the most part, you could reuse everything from your mini project individually. It should just be an exercise in you being able to do it yourself. So everything in this class up until now is either explicitly in teams or you can sort of discuss with your friends. The final exam is the only thing in this class that is explicitly no collaboration. Yeah. But you shouldn't think of the Kaggle competition as this thing where it should be a thing where you've already have some experience doing it in a team. You could reuse all your code, reuse the setup, reuse the ideas, and just do it. Yeah. Yes.
How much is the competition for?
I might be misremembering, but it's approximately 25. Well, it is approximately 25%. It might be exactly 25%. Yeah.
25%
out of the final grade. So the final exam is 100 points. And so 25% means 25 points. Yeah. It's part of the final exam. Yeah. Yes?
What's the grading rubric for the competition going to be based on this project?
Yeah, so what's going to happen is that the TAs have already created a bunch of benchmarks. So like a bad model, a medium model, a good model. And so some part of your performance is based on the process. Some part of the grade is going to be based on process. And then some part of the grade is based on being able to clear these hurdles. So, and then a very small fraction, about 5% of the grade, total grade, is an actual open competition. So roughly how it works, this might be curved slightly due to the score distributions, but roughly how it works is if you're between the lowest, if you hit the medium hurdle, if you pass the lowest hurdle, didn't hit the medium hurdle, you will get a grade that's prorated according to your linear distance between the lowest hurdle and the medium hurdle. If you pass the medium hurdle and didn't pass the high hurdle, that part of your grade will be prorated. It's about 5% each, prorated between how much you filled that gap. And then the final hurdle will be prorated against the top performing person. So if you're within, so that final 5%, if you clear the highest TA benchmark and you're within 90% of the performance gap to the top team, you will get 90% of the remaining 5%. So there's a small incentive to sort of do a little bit of a competition, but it's a very small incentive. And it, yeah, yes, yeah. The numbers will be made known to you, the methods will not.
Or like the methods on which we're grading. You said there's going to be like a good model, medium, good model,
That's all the information you'll get. I think it'll be pretty easy to tell, honestly. But I mean, we're not going to tell you what methods we use to train those models. But there'll be benchmarks on the Kaggle competition leaderboard. The simplest model is very easy to beat. Yeah.
What if our project already reached the middle?
I'm sorry, I didn't hear your question.
What if our project already reached the simple benchmark or the middle benchmark?
What if your project won?
Yeah, like the work we have already done.
A different data set.
Oh.
Yeah, it's a different data set. So I mean, the code, the pipeline, the data processing, the methodology, all transfers. It's a different data set, though. Yes?
If the methodologies from project 1 for hypertext were published, doesn't this necessarily advantage the teams who perform exceptionally well in project 1? Or the individuals who constituted those teams, regardless of their contribution to those teams?
You talk about your individual. So first of all, okay, I will say this. The data sets are pretty different, even though at a high level it's supervised learning. So this data set is on regression. It's not classification. So you're predicting queuing times. So you know, if you didn't actually absorb information about project 1, you simply just did it and you relied on your teammates, hypothetically, and you just took that code as is and just transferred it to this particular competition without understanding the process, chances are you're not going to do very well. I mean, you'll probably do okay, but you're not going to do very well. If you were part of the team in the Kaggle, if you were really an active member of the team in the first mini project, and you went through the thought exercise of how do we tune these models, how do we like schedule our compute times, and how do we like process the data, that experience will help you quickly figure out how to do well on this new data set. Even if you didn't do all the work yourself, because it's the team, if you discuss with your teammates and you learn from that experience, you should be able to do it yourself. Yes?
Do individuals on that team have a greater opportunity to learn the extent to which these approaches can be applied than people who are not on those teams, regardless of intent to learn?
I'm not sure I understand the question.
Like, there's more material to learn from. If you are an eager learner, for instance, on a high-performing team, there's more to learn from your peers or from the work of your team.
I see. So I will say that I will say that there were no like there are no secrets. Right? A systematic understanding of the data set. So like for example, if you were on a team that performed really well, and they did a few things that like really made a difference in getting the final few percentage points, which by the way is worth like 0.0001% of your final grade. But I guess you guys are all very competitive. But you know, and so if you just like reuse those exact same methods, those exact same hyperparameters, you will not win this competition. It's the thought process that goes behind it. And so it's the experience. So I don't see it as I think you should just take some of the fundamentals you've learned and how the intuitions play out in the first Kaggle competition. Those intuitions and the fundamentals that you sort of had to bring into practice. Take that wisdom and some of the code that you wrote for the Kaggle competition, and then import it to this one, and do a little bit of experimentation yourself. I do not think a straight up port with no modifications will do well. Like I mean, first of all, it's a regression problem, not a classification problem. Yes.
Yeah. So the data set is pretty different, so we cannot just like simply reuse the code. Do you have a estimation about how long we should?
The TAs will release a version of the code with features and data process that you could just run as is. If you want to spend some time to process the feature representation or the data set in a way that you think is better, you're welcome to do so. Yeah. But the TAs will release a version of the data set that has been processed, and all their benchmarks are based on that version. If you choose to go beyond that, you're more than welcome to. Sorry, what was the question here?
I was going to ask a similar thing.
Oh, okay.
That's supposed to take up to 2 hours, sort of, that's being shaved off of.
So I think in terms of absolute time spent, because you're gonna I think what's gonna happen is you're gonna come to it and leave it, because it's something you have to run. In terms of absolute time spent, you'll likely spend more than 2 hours. In terms of like cognitive load and intensity, I think it's dramatically less than the 2 hours you spend on the final that we're shaving off. So I think in terms of the absolute amount of time spent, you probably spend like 4 or 5, something like that. But I think in terms of the intensity, the cognitive intensity will be much lower, even accounting for the fact that it will be more than 2 hours. Yes?
I was just going to comment on Angela's point. I think part of what differentiated some of the teams was just having the right, literal software libraries they used, so XGBoost and 5GVM, for example, is something that Jim used. That helped them a lot compared to XGBoost. And I think if you Googled really deeply, you would find other Kagglers who wrote about using those models. I don't know if that helps in any way, but I think that was responsible for some amount of the performance differential between the teams, which software to use.
Yep. Certainly, yeah. I would say that the first thing one should try. I probably shouldn't say this. Is probably XGBoost. I think if you do a little bit of a literature search on the web, you'll find that it is the de facto standard these days. I would recommend you try a range just to be thorough, and it's not hard just to write a script that tries a range. But I would say it's a mistake not to include as XGBoost in the suite of things you try. Yeah. Yes.
I have another question, which is, I think homework, the embedding homework, where, and I read the solution for this, but I was confused. They said that if you increase the dimension, I think, of the word vectors, with the training objective, you increase or decrease.
Mm-hmm.
So I'm just curious. I get the intuition that if you increase your model complexity, your training error should always go down. But I was thinking because of if you have super high dimensionality of your model, wouldn't that decrease the training objective just because you'd have more extreme distances between vectors?
No, because you could just pull them all together.
Sorry.
You could just, okay, suppose, just for the sake of argument, I initialize all the word2vec points at the origin. This is actually really bad initialization because at the origin is a saddle point in the optimization landscape. But suppose I did. No matter how many dimensions the data is, it'll stay at the origin, right? The distance will all be 0, no matter what you did. So if you have a high dimensional space, it includes as a subset a low dimensional space that it was the previous solution. What was the entire previous learning problem? Yeah. So typically the argument is made on the basis of sets, or one typical way that the argument is made is on the basis of sets. The set of possible solutions is strictly larger than the set of possible solutions in the previous learning problem. Therefore, you can do strictly better, or at least as well. Yeah.
Another question I had was for the last homework. They were asking in question C whether or not like supervised or unsupervised training would have given us, the H&M would have given us like better results. So I'm just wondering hypothetically, if like the supervised learning, like your Ys, didn't actually correlate to like the music genre that people listen to. It's just some random noise. Would that make the supervised learning worse than the unsupervised?
Better, I forget the detail. Better or worse in terms of what task?
Let's say like generating realistic like progressions of like music things. Or more realistic like mood, like hidden state transition.
Okay. The question may be asking something specific. Was the question asking something specific or open-ended?
So it's like, I think.
Because the answer can go, the answer can in theory go both ways depending on the details of the question. Yeah. Usually, if the labels are good, I would say the supervised learning is better.
Yeah. Which do you think provides a more accurate representation of non-moods and how they affect your music choices?
I mean, in general, I would say the supervised learning is better. Yeah.
I guess just like, let's say the labels were like nonsense, like the Y's for your supervised learning were correlated to like what.
Okay, yeah, then you get garbage in, garbage out. Then the answer would be you probably want to do unsupervised then.
Okay.
Yeah.
So I guess in general, like if you had multiple, let's say you had a bunch of like X's, right? And you're trying to create an education that like models one of them in particular. Like how would you find which of the X's are like moods, that correlate to his music, and which of them are just random notes? So like a systematic way of doing that.
Are you in CS155 right now?
No.
Oh. So if you take CS155, they'll tell you one method that can achieve this. It's a non-convex optimization method based on PCA and SVD. So it turns out that you can relate, if you believe that the HMM model is appropriate, you can recover what you're asking by reducing HMM learning to an SVD problem. And that is covered in CS165. So we can proceed in a few ways. I'm happy to just to sit here, have an office hours that's recorded, or we can, end lecture early. If you have questions you would prefer to ask in private, we can just turn into just a more of like a private office hours. It's up to you guys. Yes.
I guess another practical question is, I find that with Keras, like, one of the parameters you said is batch size. And it seems to me like, okay, a smaller batch size is going to get you like faster training initially, but it's not going to convert as well. Versus like larger batch size is the opposite, right? And so, does it make sense to like train with like a small batch size initially, and then continue training with like a larger batch size?
Usually people just decrease the step size. So with smaller batch sizes, you can still converge, just with smaller step sizes.
Okay.
Yeah.
I guess the optimizer should do that for you.
That's right. So like in terms of the architecture of the optimization, I don't know exactly what Keras does underneath in the back end, but if it gets compiled to C code, it's much easier to optimize if the batch size is the same every iteration, like the way you can optimize the memory, all that stuff. And the pipeline is probably just compute and memory transfer optimized for constant batch sizes. But mathematically, you can get more or less the same behavior if you just decrease the step size as you get closer and closer to the optimal solution.
And so, why not just use like a batch size of 1?
Right, so the initial variation, right, okay. So if you could afford it, the batch size should always be the entire data set. The reason it's not is because of memory limits. So there is some, and I don't know the full details, I haven't done the whole engineering calculation, but the factors include things like parallelism, like memory transfer. If it's on a GPU, for example, the GPU has, the cache is this big, the main memory is this big, data transfer is at that rate. How many forward passes can you? Because in order to do a backward pass, you have to do a forward pass. How many forward passes can you do in parallel? If you go one over that, it takes twice as long, right? As if you just had the batch size twice as big. So these are all the things that are in consideration when these people design these methods. I don't work in the industry enough to know how those trade-offs manifest in the current data sets, the current network architectures, and the current hardware. But those are the factors that matter. Yes.
Since the capital competition was introduced for the final, and it seems like time management might be a concern for some of us, do you have any suggestions on how to review for the written part of the exam and time at the top?
Yeah, so I think the mini project one should give you some sense of like how long you can just like run some experiments and then get back to it later. So the calculus competition will be something like you take a look at the data, you play around with it a little bit, you train some models. Next day, you look at the models, see the results, debug a little bit, train some more models. Do this maybe once a day for like 3 days, and then if things go well, you're done. So from that perspective, spending about an hour to an hour and a half a day, once a day, or twice a day for 2 or 3 days, is basically what I'm expecting. And so from a time management standpoint, as long as you know how to sort of schedule experiments to run, and have the ability to just let it go and do something else while you wait, I would say that's the biggest part. Yeah. Yes?
I was mostly referencing for the written assuming that we're having to force out time for all of our classes, how can we study for the written exam, given that it's supposed to still be comprehensive about this class, but shortened in terms of points and time? How would you suggest that we study for it?
Right.
There may be a study guide that you guys can use so we don't,
Right. I'm thinking. I will say that most of the questions that we're going to ask are in the normal part of the final. The majority of them will be conceptual in nature, and a subset, and then a subset will be derivations in nature. So derivations include, here's kind of an interesting function. Can you derive the gradient? You know, stuff like that. Conceptual are things like, you know, here's a hypothetical scenario. Here's some results we got. Like, how do you reason about the bias variance trade-off? And that's like either a short answer or multiple choice. And so, you know, it won't be anything that is super monotonous for the most part. And it would mostly be questions that are fairly conceptual. And so, you know, there are questions on the homework that also, in the non-coding questions on the homework that also lean conceptual. And many of the vast majority of the final exam questions will take the same flavor. And so to the extent you would like to, so in some sense, the material is literally just the material we covered in class. The questions are really testing your individual understanding of the materials. And they're gonna lean towards the conceptual end of the spectrum. And there are many instances of such types of conceptual questions in the homeworks up to now. And so it really is just a matter of understanding the material at a conceptual level and then reviewing the types of questions we ask in the homeworks that are conceptual in nature. So, you know, just because there's very little, you know, like grunt work in the exam in terms of like do a really detailed derivation, or there's a little bit of that, but not too much. Like someone who has a perfect conceptual understanding of the exam should be able to do this exam in about less than an hour. Like it's just really, do you understand the concept, yes or not? If you need to like think for a bit to work through the concepts, then it'll take longer. Like, but it's not like, you know, like if for example, if I were to take this exam and I understand the concepts, or one of the TAs would take the exam, they understand the concepts, should be able to do it in less than an hour if they knew the concepts really well. And the time of 1 hour to 3 hours is my estimate of your time it takes for you to work through the different concepts and reason it out yourself. So it's not like I would also take 3 hours because I'm just like, you know, deriving stuff or coding stuff up. It's not like that. It's really, the majority of the questions are conceptual in nature. Yeah. What's the what? I'm sorry?
Passing, like for people who take this class.
It's a D. Yeah. A D is passing.
Oh.
Yeah. So it's curved. It's curved a little bit, so I can't give you an exact cutoff, but it's around 60 to 65%. Total grade, yeah, total grade, yeah. Yeah, so the final grade is curved slightly, because I'm looking for natural cutoffs. So like an A minus is something anywhere between 89% to 91.5 or 92. So it's always going to be curved just a little bit because I want the margins to be the most natural breakpoints possible. But roughly speaking, it's a fairly standard grading rubric. Yes?
So, if I remember correctly, most of the derivations that I recall doing that were or like a little bit extended in nature were from the past two homeworks. Should we expect that the conceptual exam be evenly spread throughout the...
Yes, you should expect to be evenly.
Even though
Hold on.
the derivations happened in the last two.
So you did derive gradient descent. You proved the convergence of exponential loss. We're not going to make you prove something like that in the final. That's too involved. But you did prove that, right? And there's some conceptual questions. Like, you know, you have to prove that the exponential loss upper bounds is 0, 1 loss. The exponential, you're doing gradient descent in function space, minimize the exponential loss. Like you prove that relationship. We're not going to ask you to do a full proof like that in the final exam. That would basically take half the exam in terms of time budget, or a third of the exam. So we're not going to do that. But those are conceptual questions. Like there might be elements of that might be asked. In terms of the second half, you know, there are questions of like initialization. Like if you have a non-convex optimization problem, how important is initialization? There are questions of like local optima. There's questions of maybe just, I don't know. I don't know. I'm giving the TA a little bit of leeway to modify the exam, so I don't actually know exactly everything's on the exam. I think that's good because now I can say stuff that I don't know with full confidence if it's on the exam or not. But things like, you know, if the neural net gets deeper, how much more expressive is its representational power? You know, why is a convolutional neural net better than a connected neural net for certain types of applications? These are conceptual questions that may happen and are material drawn from the second part of the class. But yeah, I guess on average, I would say you're right in that because the second part of the class had more mini projects, all the mini projects were on the, I mean, except for mini project 1. Two out of the 3 mini projects were in the second half of the class. Actually, 6 homeworks, 3. Yeah, so I mean, yeah, so I think the courses will be biased towards the homeworks in the first half of the class simply because there were more homeworks in the first half of the class. And relatively less emphasis will be drawn from mini projects simply because, you know, that those mini projects intended to serve a different purpose. And there were more things like, you know, recent topics, deep generative models, these lectures that won't go into the exam, but just for your personal enrichment. So those, again, are all largely in the second half of the class. Yes?
Are there data sets for any roles enriched in global optimum? Like some
If you have one, if k equals 1, it'll always converge to global optimum. I think that might be it. Even in a one-dimensional data set for k equals 2, I don't think it's guaranteed. You can have 2 clusters that are, I don't think it's guaranteed. Yeah. No. Let me think. In 1 dimensions, is it guaranteed? In 1 dimensions, I don't know the answer. I feel like even in 1 dimensions, it's not guaranteed to global optimum. I'll have to think a little bit, but certainly for more than 1 dimensions, you're not guaranteed to converge to global optimum. I don't know the answer for 1. Yeah. So in general, I would say the answer is no, like for any practical problem. Yeah. Okay, so what I'm going to do is I'm going to hang out here for the next 45 minutes or until everyone leaves. And I'm just going to turn the camera off in case you have questions you don't want to ask in front of the camera. This is the end of the lecture. The final exam, I know it's always stressful, especially since this is the only thing in the class that you do completely on your own. But I do think it's important to test that. And again, if you're interested, CS155 is also offered in the winter term. It's Foundations in Machine Learning. It's taught by Nima Anand Kumar. So if you find this stuff interesting, you're interested in more of the mathematics that underpin this, I would encourage you to take CS165. And CS159 being taught this upcoming spring is a research project we do in